Hello dear students, let's continue our discussion on linear queue implemented by using array. In the previous video, we saw how to insert a new value in linear queue. So we have seen how this insert function inserts values in the array. Every insertion always increases rear by 1. Rear counter is increased by 1 during every insertion. And if it is the first insertion, then front must be -1. If it is the first insertion, this condition will be true and we will forcibly make front equal to 0. All these things were seen in the previous video. In this video, we will see how to delete a value from a linear queue. So this delete function will not only delete a value but also return the value. So the return type of delete is integer. Like as you see the queue drawn here on the right hand side. First time when you call delete, it's going to delete 10, isn't it? Because 10 is the frontmost element of this queue. So this function is going to return 10 back to main. Let's see how main is going to call delete. Here is the menu in main where the second option is meant for delete. So if the option entered, the choice entered by the user is 2, then case 2 will become true. And in case 2, very importantly, you just check in case 2, we are first checking is the queue empty. Well, if the queue is empty, so the empty function is called which will check whether the queue is empty or not. Well, all of you know that the queue is empty if front is -1. So if front is -1, this function empty is going to return 1. 1 means true. And if true is returned, then the brackets of the if, you notice, is having true value. So the condition is true. It means that the queue is empty. In that case, the program will display queue underflow. That's there is nothing to delete in the queue. Whereas if empty returns false, indicating that the queue is not empty, then this if is false. So we will land in else and we will continue to call delete. So carefully main is calling delete. You see, main is very careful. Main will first inquire, is there anything to delete? If queue is not empty, only then the delete function is called. And notice again we are passing address of the queue here, and whatever is deleted, say 10, 20, whatever, is stored in Z, which is an integer variable, and finally we print data deleted is Z. So let's see how to delete a value. Let's go to delete function now. Here we are. This is the status of the queue right now. Queue has 5 values, 10, 20, 30, 40, 50, where front is 0, obviously. Front is 0 here and rear is 4. So what do you think? If you call delete, 10 should be deleted, isn't it? Because that's the frontmost. Okay, run the code with me. There is a local variable x here, and we say x, you store frontmost element of the array. By frontmost, here we mean 0, because the value of the front, as you see in the box there, is 0. So a of 0, which is 10, is stored by x. So x is 10 here. The idea is that finally we are going to return x. See the last line. So 10 will be returned back to the main. But before that, there is a if here. This if makes a lot of sense as far as queue is concerned. Check that in the if we are asking, is p arrow front equal to p arrow rear? Now watch, p arrow front, I'll write it here again. P arrow front is 0 and p arrow rear is 4. By the way, p, as I did not tell you this because this has been told number of times in the earlier videos, p is a pointer which stores address of the queue. Remember, we are passing address of the queue to delete. So delete function has p which is pointing to the queue. So by p arrow front and p arrow rear, we mean this front and rear. And we are comparing, are they equal? Come on, this time they are not equal. Front is 0 and rear is 4. So we execute the else portion where we say front plus plus. Hence front which is 0, here I am updating, check it in the box, front will become 1. The idea is so easy. We are pulling out 10, isn't it? If 10 goes out, then 20 should become the frontmost, and 20 is stored at first location. And finally return x, that means 10 is returned, and that's the end of delete function. Watch that delete function is straightforward. If there is a queue and frontmost person is getting out of the queue, then the next person should become frontmost. That's it. That means front plus plus. This statement is the summary of the delete function, isn't it? Now I want to discuss a few things here. Is that if you are thinking about this, then really I appreciate. Just check. We had 10, 20, 30, 40, and 50 in the array. And front is 0 and rear is 4. Now we are saying that 10 should be deleted, isn't it? And what we did is we said, okay, front was 0. Now let's make it 1 because 20 is the frontmost. The other idea could have been that if we are removing 10, how about copying 20 at 0th place, then 30 at first place? That means pushing all the elements of the array one place to the left. Okay, so now the front will remain 0. See how 20 is the frontmost and front will remain 0, but notice 50, this 50 which I am encircling was at 4th location, but it has come to 3rd location, so rear should be decreased by 1. This can be another strategy to delete a value. We can push all the elements one place to the left, and that's the way how real life queue works actually. If this is a service counter, just imagine, and some people are standing in the queue waiting for service, and if this person finishes the work and gets out, then obviously this person is shifted up, isn't it? Shifts ahead so that all the people shift ahead. So this person obviously becomes frontmost. But then why are we not doing this? What we did actually is after deleting 10, observe, after deleting 10, here we go, we did not push 20, 30, 40, 50 ahead, but we simply said, okay, front was 0. Now let's make front equal to 1. Why didn't we push these values one place to the left? Yeah, you must have answered the question. The answer to this is this will be time consuming. Pushing the values one place to the left requires a for loop because we will have to run all the way from 1 to 4th location. So for I is equal to 1 to 4, these elements one by one have to be pushed to the left side by one place. And what if we had a queue of 1000 elements? What if we had a queue of 1 lakh elements? Pushing so many values after each deletion will be very, very costly in terms of time. So we have used a simple policy rather to increase front by 1, isn't it? So this is what the textbooks teach us. Instead of pushing all the elements one place to the left, which will be time consuming, the classic algorithm of deleting a value from the queue is simply say front plus plus and then return the value that you have just now taken out, that is 10. Let's continue executing delete for some more times. Let's say we execute delete again. This time 20 should be deleted. What do you say? Because x will be equal to front element of the array and front element is now 1. Check the box, front at the moment is 1, isn't it? And that is 20. So x is going to be 20. And then we again ask, is PRO front equal to PRO rear? No, it isn't, because front is 1 and rear is 4. So we land in else, and in the else we simply increase front by 1. Definitely then front, which was 1, will now be 2. Come on, if we are deleting 20 and returning 20, then the queue now logically starts from 2nd place and ends at 4th place. I hope you have understood delete. More to come on this. Just keep checking. We are heading towards a very interesting discussion. I'm sure you have understood each and every line of this, but the question remains, why is that if statement written? Is front equal to rear? Just imagine you delete 30 and you delete 40. So now front is going to be 4, isn't it? Front is going to be 4 and rear is also 4. Observe, there is only one element in the queue. All the other elements are deleted. Okay. And now if you call delete again, surely X will become 50 because that's the frontmost. Check that front is 4. So X is 50. And now comes the question, is front equal to rear? And it is. Front is 4 and rear is also 4. Now you just tell me, if you are deleting 50, then is there any sense in saying front plus plus? Can you say front becomes 5 and rear remains 4? Hello, if front is equal to rear, if both the counters are equal, it means that there was only one element in the queue pending, and even that is getting deleted. If front and rear are equal, then the queue is going to become empty. Then we will abruptly make front and rear both as -1. Look at the big change. After deleting 50, both the counters are going to become -1, and it has to be. It has to be. You can't say front plus plus. You can't go to this else part and say front plus plus. So that's the importance of that particular condition. I hope you have understood the entire delete. Of course, there is a function called empty, which is always necessary before you call delete from main. And the condition is, if front is -1, come on, then return true because the queue is empty. Otherwise, return 0 because the queue is not empty, so return false. Just don't leave this video. I got some more things to tell you what happens really now in the linear queue. So just imagine that we have such a queue again where we have array with the values 10, 20, 30, 40 and 50. Okay. And front is 0 and rear is 4. Imagine one deletion. Now we are not reading this code anymore. So 10 goes out, then front becomes 1 because 20 is the frontmost. Okay, delete one again, one element again, 20 is deleted, so front becomes 2. Okay, so we have executed delete 2 times. And suddenly, user feels that we want to insert one more value, 60, say, one more value. So user calls insert function. Now you tell me, is there any room in the queue? Pause it. Wait a minute. Is there any room in the queue? Can you insert 60? Of course you can, because you watch that these two elements are empty. Queue is not overflown, but insert function will announce overflow. Just check insert function. Let's scroll up. You want to insert 60, a new value in the queue. And so rigidly, the condition written in the linear queue program is rear. Watch that rear is 4. Is it equal to 5 minus 1? Which is true. So it's going to announce overflow. Yeah, really, rear is 4. Watch this. Because 50 is stored at the 4th place. And it simply says, look, rear is at the last element of the array. So 60 can't be inserted. But actually, two elements are vacant. Isn't it so? The height will be, if you have deleted 30 and 40 also, that means front is going to be 4 and rear is also 4. Now this queue is virtually empty. Only one element is there in the queue, and you want to insert a new value 60. You call for insert, and insert is going to announce overflow, because it simply checks if rear, I'm writing in short, if rear is equal to size minus 1. If rear is equal to size minus 1, if it is true, overflow. But so many elements are empty, you see. This is disadvantage of linear queue. You can call it as disadvantage, yes, but if you try to delete, then again insert, then delete some values, again insert, then you will get this problem, because queue is not shifting ahead. Have you found out that in real life, queue is not shifting ahead? So very soon, the array will be full and rear will reach the last location of the array. In that case, even if the queue is virtually empty, it will announce overflow. This disadvantage will be removed by circular queue using arrays, which we will see after this topic. But then when we join, again, we will see another function called display, how to display a linear queue. Thank you very much.